As a second limiting reactant problem or example, let's look at ammonia and oxygen when they react, and it turns out they form, if we look carefully here, they form nitrogen monoxide and they form water. We can easily put that reaction together and balance it, which you see here, 4 ammonias, 5 oxygens, 4 NOs, which is the nitrogen monoxide, and then the 6 waters are formed. We're starting with, looks like 3 grams of each. And I've put together the calculation to find the limiting reactant. So let's just walk through each one of these real quickly. We asked the question, how many grams? Because they asked about what mass, we're going to go to grams this time instead of moles. But how many grams of NO can we make? We're starting with 3 grams of O2. This right here is the molecular mass of O2, 32 grams per mole. So we get to go from grams per mole. From the periodic table, we get that information. From the balanced reaction, then, we can see that for every 5 moles that we will use, we will create 4 moles of NO. And then from the periodic table, we can go ahead and convert from moles to grams and find that we make 2.25 grams of NO from this amount of O2, or we can make that much. We do the same thing for the ammonia. Once again, 3 grams. Go to the periodic table, we go from grams per mole, grams to moles. So we're sitting here at moles of ammonia, and we use the reaction here. This is from the reaction. 4 moles and 4 moles and 4 moles. Get rid of that one. And then once again, we use the periodic table. It turns out we can make 5.28 grams with this much ammonia. So as we've done every other time, the smallest amount we can make is the amount that we will make, because when we get to this amount, we run out of oxygen to make any more, so we can't make that much. So that's the limiting reactant problem. What other things might be asked now that we've done that part? Well, it turns out we could ask this question. The question that we could ask would be maybe, how much NH3 remains after the reaction? Now that we know that we run out of oxygen, how much NH3 remains? That would be an interesting question to find out. We could also ask how much water we make. It'd be the same question we asked before, but from now that we've done this one problem, we can use the fact that this is how much O2 we are going to use. So we're looking for the number of grams of NH3 that's remaining. So we're going to have to try to find the number of grams that were used and then subtract that. So what we know is this. We know that there's going to be 3 grams of O2 used. And we know that there are 32.00 grams of O2 per mole of O2. Where do I get that? Once again, that's from the periodic table. That's where this all comes from. Then I know for every, I need to get a little bit more room up here, for every 5 moles of O2 that I use, I will also need to use 4 moles of NH3, or the ammonia, and then I can find from there 1 mole of NH3 is the same thing as saying that I've got 17.04 grams of NH3. So I get this from the periodic table, this comes from the balanced reaction, and I can find out how much I'm going to use, which is going to be 3 divided by 32, multiplied by 4, divided by 5, multiplied by 17.04. Turns out that I'm going to use 1.278 grams. Therefore, if I want to answer this question, the number of grams of NH3 that remain will be equal to 3 grams. The 3 grams that we initially had minus the 1.278 that we're going to use here. That means that I'll have 1.72 grams of NH3 remaining. So another limiting reactant problem and the stuff we can do with it when we're done.